Assalamualaikum and greetings. So we are from group 2. We are going to present on our project. In our group we have Samuel, me, Ahmad Razin, Hazlina Fazrin, Muhammad Lutfil and also Amirul Aiman.
Assalamualaikum, my name is Amirul Aiman bin Nasir, AF220012, and I will present introduction. For this part, topography describe the physical feature of the Earth's surface, such as elevation and landform. This feature play an important role in hydrology because they influence how rainfall flow across the land and enter river system. To understand river behavior, hydrologists often use a hydrograph which shows change in river discharge or water level over time. Hydrographs are especially useful for analysis flood events. In this study, a river station along Sungai Johor was selected due to the area frequent flooding. Google Earth Pro was used to delineate the catchment area and identify high ground, which defines the catchment boundary. This information formed the basis for further hydrological analysis. For study area, the location we selected was Kota Tinggi. Kota Tinggi is located in eastern Johor and is known for a low-lying terrain. As a result, the area is highly vulnerable to flooding, particularly during the northeast monsoon season when rainfall is intense. The Sungai Johor drains a large catchment area that include forests, agricultural land, and urban area. Before flowing into the South China Sea, flooding frequently occurs along this river due to heavy rainfall, flat terrain, and significant upstream runoff. This condition makes Sungai Johor a suitable location for studying rainfall runoff relationship. And for the objective of this study, first, to determine the rainfall and water level data at a selected river station. Second, to calculate and plot the unit hydrograph for the chosen river and station. And the last one, to identify the peak flow of the river, which is important for flood analysis and river management.
Alright, so here we are going to talk about the methodology that we used. The study area. We have selected the Sungai Johor watershed, Kota Tinggi Johor, and we also identified it for the hydrological and flood analysis on that specific area for the watershed. So the next one, data collection, rainfall data from three locations, Sungai Johor, Sungai Lingyu, and also Sungai Kepala Orang. River water level and discharge data from Sungai Johor that we collected for this project. The next one is rational method. This method was used to estimate peak runoff based on rainfall intensity, catchment area, and also runoff coefficient. Cross-sectional analysis. River cross-section at maximum water level was used to calculate peak flow. Data processing. Data checked for completeness, consistency, and errors. Hydrograph development. Hydrographs that we have plotted to identify rising limb, peak discharge, and recession limb. Comparison analysis. We peak discharge from rational method and cross-section calculation we compared them to excess reliability. The last one, results presentation. Findings presented using graphs, tables, and also brief explanations on each graph.
So next, in this slide, I will present data presentation. For this project, we need to choose 3 stations that nearest to our outlet to collect rainfall data with the highest rainfall based on public info Banjir website and Google Earth. First, Sungai Johor di Kota Tinggi. So for this station, it shows that December has the highest rainfall. So second station at Sungai Lingyu di Lingyu. So at this station, March have the highest rainfall. So the last one is at station Sungai Kepala Orang at Kampung Srijaya. For this station, November have the highest rainfall. So now I would present for water level for each station. So for Sungai Johor di Kota Tinggi frequently show that the water level reach danger level. Next, station Sungai Linggu reached alert level that water level increased above normal level by the end of the month. Lastly, station Sungai Kepalaurang. For this station, even though March is the higher rain, but the water level still remain to the normal level.
Assalamualaikum and good evening. My name is Muhammad Filhadi bin Saiful Azman, and today I would like to present to you all about analysis of our project, which is the first one is rainfall analysis. So the rainfall station at the center of this catchment area was chosen for the analysis of the rainfall data. As you can see, the next to the statement, which is hydrograph by station Sungai Johor di Kota Tinggi. So the highest rainfall event in within 1 year is selected between the year 2025 to 2036, and between that year, which is on the month of 2025. The three highest rainfall event occur within that month, which is on the 20th, 12th, and on 30th, 13th of March of 2025. So for the next one is I want to present the water level analysis is done by using the data of the water level from the date with the highest rainfall data, which is from the hydrograph for station Sungai Johor di Kota Tinggi. The hourly rainfall depth for the 24-hour period on 17 December 2025 were examined to identify patterns, intensity, and total volume. The recorded water levels at the stream gauge were plotted against time. So you can see from the hydrograph, uh, the date was fixed, which is on 17/12 of 2025, and also the time, the other parameter, which is the time and water level. So from the zero of the time, the water level is on 1.72 meter. The next interval, which is from time, the interval of the time is 1 hour to 1 hour. So the next hour, which is on the 1 hour, water level decreases by 1.47 meter. So for the next one is flow calculation using Manning equation. So from the area, from the catchment area, we get the upstream, midstream, and downstream. And this picture was the cross-sectional area for our catchment area. So the channel parameters are base width, which is B, is 60 meter. Side slope, Z, is equal to 2 horizontal and vertical. And the three parameters, which is Manning roughness coefficient, and we use the 0.035, which is typical for natural streams with some width and stone was exist on our catchment area. And the fourth one is a bed slope, S, which is 0.0005 that we obtained from a Google Earth terrain profile. So this is the calculated data that we obtain for the trapezoidal shape. So for area for trapezoidal, as we know, is area equal to yb plus zy, and then we must find the weighted perimeter for the trapezoidal shape, which is weighted perimeter equal to b plus 2y square root 1 plus z power of 2. And then we must use the other formula, which is to find the hydraulic radius, which is R equals to A over P. And then we can get the discharge of the water uh, for this data. So the next one is unit hydrograph derivation. So the concept of the unit hydrograph is applied to standardize the catchment runoff response. The unit hydrograph UH for the catchment, which represent the direct runoff respond to 1 unit, which is 1 millimeter of effective rainfall uniformly distributed over the catchment and duration. So we can see from the graph, we have the discharge and the times. So the total direct runoff volume is calculated as VD equals to total QD multiplied by the change of time equals total QD multiplied by 3600 second, and then we get the VD equals to 1005 one 154,260 meter cube. So the effective rainfall depth is calculated as runoff depth equals to VD over A. VD we get from the total direct runoff volume, which is 154,260 meter cube, divided by 398.33 kilometer square, and then we get runoff depth equals to 1000 and 0.38 centimeter. So the next one is a rational method. So for the rational method, we must find the runoff coefficient C. What the function of C, which is to determine the runoff coefficient according to mass second edition. The runoff coefficient for the area is 0.30 and 0.95. However, when the catchment comprises multiple land use type, the average runoff coefficient must be calculated using the formula provided in the MASMA second edition. So using the formula, which is we must to find the C average, and then we get the 1.55. So the next one, we must find the overland sheet flow path, which is L. The length of the overland sheet flow path was estimated using Google Earth Pro with a calculated distance of 53.2 kilometer. As we can see at the screenshot of the picture of from the Google Earth Pro. So to find the slope of the overland surface, we use the formula S equal to HF over I multiplied by 100%. So we get from the calculation, which is 0.21%. For the next step, we must find the time of concentration, which is TC. TC is the amount of time it takes for runoff to get from the watershed farthest distant point to the catchment outflow. So we assume that TC equals to TO. So using the formula, length times by TC, which is for our length just now, is 53,200 meter times 0.83, and then we get the 44.1 kilometer. So to find TO, we use the formula from the MASMA, and then we get the time of TO equals to 233 minutes. So the next one is rainfall intensity. Intensity is the rate at which rain falls on a given area, expressed as the amount of rainfall depth per unit time. It represents how concentrated or heavy a rainfall event is over a specific duration. So, due to the unavailability of water level at station Sungai Johor, the IDF constant from store JPS Johor Bahru is used because the IDF constant of station Sungai Johor is not there on the MESMA second edition. So we use the other station because the store GPS Johor is the nearest representative station at Sungai Johor. So they given and we use the constant parameters that they give on the MESMA. So using the formula, we get the rainfall intensity equals to 32.6 millimeter per hour. So for the last one, from the rational method, which is we must to find the peak runoff QP. Peak runoff is the maximum rate of a surface runoff generated from a catchment area during a rainfall event. So we use the formula from the MESMA, which is QP equals to I times C times A over the 360 uh, on the formula. So using the formula, peak runoff, we get the QP is equal to 5,591 meter cube per second.
Good day, everyone. My name is Ududaya Samuel Oluwasegun. I am going to be presenting the discussion of this project. For this project, there are three main content we discuss in this project. The first one is the rainfall runoff relationship. The rainfall runoff relationship describes how precipitation turns into water flowing over land, which is known as runoff. This is controlled by rain intensity, soil type that determines the infiltration, and the land cover, with runoff occurring when rainfall exceeds soil absorption. Secondly, the hydrograph and base flow separation. An hydrograph shows the stream flow over time. It can be calculated using methods like the straight line method, the fixed base, or the variable slope technique. For this project, the method used is the straight line method. It, it has an average base flow of 2.84 millimeter. And lastly, the peak flow estimation. The peak flow estimation is used to determine flood risk and for the management of flood. Methods used in determining peak flow include rational method and unit hydrograph. The rational method was used for this project and the peak flow is approximately 1.5 mm. In conclusion, this analysis successfully demonstrates catchment response to a storm event. Also, we are able to see that this catchment area is prone to flooding due to its low-lying terrain. The proposed solution to mitigate this is by building a reservoir in this area, and channel improvement and dredging should be considered. Thank you.